All right, so we're going to continue on with graphing quadratics or parabolas. So I hope you guys are doing all of these with me. It's going to be hard for you guys to do them on your own if you don't practice with me. All right. So the first thing we're going to do for this quadratic, which means the exponent is 2, is we're going to find your x-intercepts, which means we're going to set the function equal to 0. So we're going to think of two numbers that multiply to give us -3 and add to give us -2. So that would be x minus 3 and x plus 1. Right? Because -3 times 1 is -3 and -3 plus 1 is -2. And since we're setting y equal to 0, we want to figure out what the value of x is by adding 3 to both sides and subtracting 1 from both sides. So the x-intercepts are +3 and y is 0, and also -1 for x and y is 0. Okay. All right, let me get rid of this. I don't want to erase everything. That's why I got confused on my last video because I forgot what number I erased. Now, to find the vertex, you're going to have to write this formula down and you're going to have to remember it. So to find the vertex, we're going to do -b over 2a. That's also, if it's a happy positive parabola, that's the maximum value, the maximum height or the minimum, right? And this is our vertex. Vertex. And actually, it's the x value of the vertex, okay? So our a is 1, is our leading coefficient. Our b is -2, and c is -3. We don't need it right now, but we'll use it later. All right, so the opposite of -2 is +2, and then 2 times 1, what I did, I wrote b. I say the right number and I write down the wrong thing. All right, so the opposite of -2 is +2, and then 2 times a, which is 1. So we have 2 over 2, which is 1. So our vertex, the x value of our vertex is 1. Y'all remember how to find the y value. To find the y value, we take the x value, we plug it into the whole equation, and we figure out what our y value is. So if x is 1, I have 1 squared minus 2 times 1 minus 3. So 1 squared is 1. Minus 2 minus 3, so that would be -4, right? There we go. All right, so let's look at the points we already have. So right now, if we were filling out a little t-chart, we would know our vertex is 1, -4. Our other 2 points, our x-intercepts are -1, 0, and 3, 0. And the way I like to write them like this so I can see exactly what's on both sides of the vertex. I put the vertex in the middle. So let's go ahead and graph 1, -4. That's our vertex, our minimum, because it's a happy parabola. It's our minimum value. Our x-intercepts are -1, 0, and 3, 0. So we want 2 points on both sides of our vertex. So obviously a 2 could go here and a 0 would go there. And since parabolas are symmetrical, we should get the same value for y because these two numbers, 0 and 2, are the same distance from the vertex. So if I plugged in 0, 0 squared is 0, minus 2 minus 0 is 0. So if x is 0, y is -3. And then if we plug in 2, 2 squared, minus 2 times 2 minus 3. 2 squared is 4 minus 4, which is 0. 0 minus 3 is -3. So 2 other points besides the vertex and the y-intercepts are 0, -3, and 2, -3. 0, -3, and 2, -3. All right, and there's our happy parabola. Woo! I don't know why lines are so hard for me. All right, now once Again, the line of symmetry. So the vertex, if we bent or we folded our parabola together at the vertex, that both sides would lay on top of each other. And so how do we write the equation of this vertical line right here? Well, it's x equals, the line of symmetry is x equals the x value of our vertex, which is what we got when we use negative b over 2a. When we use negative b over 2a, we got x equals 1, and that's the equation of this line of symmetry, this vertical line. Okay, so now we've done 2 total from both videos, so let's do another one. Now this time, if you notice, our leading coefficient is a negative number, right? So you should know, hopefully, that our parabola is going to open down, or it's a sad parabola, right? It's frowny face. So the first thing we're going to do is find our x-intercepts, which means we're going to set y equal to 0. So we have negative x squared minus 2x minus 3. All right, so in order to, what's it called? Simplify this, or not simplify, factor. We're going to make our leading coefficient a positive because it's a little easier to factor that way. So if we divide every single term by -1, this is what we get right here. Now this doesn't mean now we have a happy parabola, no, because if we simplify this, we would distribute that -1 back. But for now, we're going to ignore that -1. We're just going to think of 2 numbers that add to give me 3, excuse me, multiply to give me 3 and add to give me 2. Uh-oh, that doesn't work. That doesn't work. How about, I'm going to change the original equation. I'll try to change it on your PowerPoint before I post it, if I can remember. All right, so we're going to change this. I don't want to give us a complicated one. So I'm going to just go ahead and change that original equation. I'm going to pretend like that was it originally. So that means, no, that's still not going to work. That would also have to be a positive. All right, that would also have to be positive. Okay, we're going to change the original problem. So pretend this was it originally, okay? So then when I simplify, or excuse me, when I pull out a -1, I end up with this, okay? And then the 2 numbers that multiply to give me -3 and add to give me -2 would be -3 and +1, okay? So it's still a negative parabola because we didn't change the original leading coefficient. But anyway, so if we set both of these equal to 0, we have that x is equal to both. We would add 3 and subtract 1. So x is equal to 3 and -1 are our x-intercepts. So x-intercepts is what the x value is when y equals 0. So we're going to do 3, 0, because y is 0. And then we're going to do -1, 0. Okay? All right, let me get rid of all this stuff. So now we're going to go back to our original equation, and we are going to figure out what the vertex is. Okay? So the vertex is -b over 2a. Actually, that's the x value. Now this time, since it's a negative parabola, that's going to be our maximum value as well. Our vertex is going to be our maximum value. So our a is -1 and our b is +2. So the opposite of +2, the opposite of b is -2 over 2 times a, and a is -1. So we get -2 divided by -2, which is equal to +1. So our vertex's x value is +1. And in order to find the y value, we have to plug in 1 for x in the original equation. So let me pull that down. So we're going to do negative, or the opposite of x squared, plus 2 times 1 plus 3. So 1 squared is 1, and then the opposite of 1 is negative 1 plus 2 plus 3. So that would be 4, right? All right, there we go. So now let's do our little t-chart and see the points that we have. So our vertex, I'm going to put in the middle, 1, 4. I'm going to put the other points on both sides of the vertex. And so now the next problem tells me I need 2 points besides the vertex and the x-intercepts. So 2 numbers between the ones that I have written here are 0 and 2. So when I plug in 0, 0 squared is 0, 2 times 0 is 0, and 0 plus 3 is positive 3. And then when x is 2, it's going to be negative 2 squared plus 2 times 2 plus 3. So we have the opposite of 2 squared, which is negative 4, plus 4, which is 0, and 0 plus 3 is 3. So now let's graph all our points. So we have negative 1, 0. We have 0, positive 3. We have 1, positive 4. We have 2, 3. And we have 3, 0. So there is our parabola that faces down, right? This is our maximum height. Our maximum height is 1, 4. Also, our vertex is 1, 4. And then we're going to take our vertex and we would think, okay, if we folded it right there and laid it together, we'd have the same picture on both sides. And so what is this equation? What is this equation of this vertical line right here? Well, it's x equals 1. And it's always the x value of the vertex. That's the whole answer. If you just wrote 1, that's not an equation of a line, right? So there we go. So now we've done a total of 3 of those. So I hope you're kind of starting to see those. So let's do another one. All right, here we are going to find the x-intercept. So we're going to set this equation equal to 0. So in order to do that, let me rewrite it right here. And then when we factor it, we always want our leading coefficient to be a positive. So I'm going to factor out a negative 1. Did I do it again, you guys? I did. I thought of 2 numbers. All right, so once again, I'm going to change. I'm going to change, I guess I have to change both of them for it to work. Or no, I don't have to change both of them. I'll just change this. Sorry, I should have thought about this earlier, but I didn't. All right, I'm just going to change that one. Okay, so my original equation. So this is my original equation. Okay, so when I rewrite it, when I factor out that negative 1, this becomes a plus and this becomes a minus, right? I'm factoring out because all I'm doing is trying to get my leading coefficient to be a positive 1 so I can factor it easily. So I'm ignoring this for now. So this is a positive x now. So I want 2 numbers that multiply to give me negative 2 and add to give me positive 1. So that would be positive 2 and negative 1. Let's check it. Does 2 times negative 1 equal negative 2? And does 2 plus negative 1 equal positive 1? Yes. So I'm good now. The way I had it written, I wouldn't have whole numbers. I just want to do whole numbers because we're just starting to do these for the first time. Anywho, all right, when we set these equal to 0 and we solve for x, we get 2 values. X is equal to negative 2 and positive 1. So those are the x values of our x-intercepts. And of course, y must equal 0. There we go. All right, y'all remember how to find the vertex, negative b over 2a? Hopefully you do. Let me get rid of all the stuff on the bottom. Go away, go away, go away. All righty, let's figure out, going back to our original equation, a is -1 and b is also -1, okay? So we're gonna do the opposite of b. Well, b is -1, the opposite of -1 is +1, and 2 times -1, 1 over -2, so we have -1/2. So that's our x value. And now to get our y value, oh no. To get our y value, we're going to plug in -1/2. So we're going to do the opposite of, what was it, -1/2? Did I do it again, you guys? I just erased it. Dang it. 1 over 2 times -1. Yeah, that's correct. All right, so we're going to do the opposite of -1/2 squared minus x is -1/2 plus 2. All right, so -1/2 times -1/2 is positive 1/4. But then you have to make that the opposite of -1/2 squared. And then minus the negative, we're going to do plus 1/2 plus 2. So I'm just going to use my calculator. I'm going to convert that in my head. So we have -0.25 plus 0.5 plus 2. And I got 2.25. I didn't know these were going to be decimals, but here we are. It's fine. We'll figure it out. All right, so now we want two numbers besides the y, the x-intercepts, and our vertex. So let's write these on our t-chart. So our vertex is -1/2 or -0.5, right? This is 2.25. And then we have a point up here at -2, 0, and down here we have one at 1, 0. All right, so let's use a whole number in between these two. A whole number in between these two would be -1, and let's use 0, right? Yeah, that should work. All right, so when we plug in -1 and 0, first of all, let's do the 0. 0 squared is 0, 0 minus 0 is 0, and 0 plus 2 is 2. So hopefully when we plug in -1, we get the same answer. So we're going to do the opposite of -1 squared minus -1 plus 2. So -1 squared is 1. The opposite of 1 is -1. And then we do bam, bam. -1 plus 1 is 0, and 0 plus 2 is 2. So these are our two other points. All right, so let's graph these. -2, 0. And then we're going to do -1, +2. So first of all, did you notice we're going to have a parabola pointing down? And then we're going to do -0.5 and then up 2 1/4, barely above the 2. And then we're going to go 0, 2 right there. And then we're going to go 1, 0 right there. So we have this thing right there. All right, and then our line of symmetry is going to be x equals the x value of our parabola, which is, we could say -0.5, or we could say x equals -1/2. It doesn't matter. So there we go. I didn't mean to get a decimal, but it all works out the same anyway. All right, now the thing about cubic functions, when our leading coefficient or when we put it in a standard form, when we find it's to the third degree, you can't, unless you do more math, like calculus style math, you can't really figure out exactly what the graph is going to look like, but you can estimate it. So remember when I told you, when the leading coefficient is positive, think of a positive slope goes up and to the right. So it's going to start and end in a positive little thingy, right? It's gonna go up, come down, and then go back up at the end. So it ends and begins the same way. And in this case, it's going to go up and to the right. And then what we can do is we can figure out the 3 zeros, right? We can figure out, remember when we what's that word? Why do I keep remembering? I mean, I keep forgetting how to say, not simplify, but, oh my goodness. Figure out those numbers that when we set them equal to 0, that's going to be our x values. So what we're going to do, since we have 4 terms, I'm losing my mind, you guys. We're going to group them, and then we're going to say, okay, well, these first 2 terms, they have an x squared in common, right? We can factor out an x squared. So x to the third divided by x to the square, x to the second is x minus 1. And then from this group, we can factor out a negative 16. If we factored out a negative 16, now those 2 parentheses are going to match, right? So one of our factors is x minus 1. Then we're going to put these 2 factors together. So we get x squared minus 16. But we don't have 3, do we? But then when you look at this one, you realize, oh, wait, this is the difference of squares, difference of perfect squares. So we find the square root of x squared, find the square root of 16, and then one gets a plus and one gets a minus. And then we bring this one down. So if we set each of these equal to 0, so what we're doing is finding the x-intercepts. So we set our whole function equal to 0. We would subtract 4. So one of our values is x equals negative 4. The other one would be positive 4. And the last one would be positive 1. Okay? So those are our 3 x-intercepts. So when so our x-intercepts is negative 4, 0, 1, 0, and positive 4, 0. Positive 4, 0. All right. And then the other thing we can find, so those are our 3 x-intercepts. So let's go ahead and graph those. 1, 0, and positive 4, 0. No, that should not be. One, 2, 3, 4. Hey. No, but thank you. No, thank you. Yeah. Okay, I'm sorry, guys. I was thinking of I was thinking they should be the equal distance apart, but I was thinking of a quadratic, and these are cubic functions. All right. So now what else can we use in order to sketch this graph before we check it and see how close we are? Well, besides our x-intercepts, we can always find also our y-intercepts, right? How do you find the y-intercept? Well, you set x equal to 0, okay? So I'm going to set x equal to 0 so I can figure out where this graph will cross the y-axis. So I'm going to plug in a 0 for x there, plug in a 0 for x there. There we go. So 0 cubed is 0, 0 squared is 0, negative 16 times 0 is 0. So basically I get 0, 16. 0, 16. So it would cross, my graph would cross the y-intercept way up here at positive 16. Way up here at positive 16. And then I don't know why I erased this. So basically my y-intercept will be way up here, but I do know this. I do know my line starts out as a positive slope. So I know it would have to come up like this. Ooh. It would probably go way up there. And then it's gonna, when it starts to come down, I'm out of room. When it starts to come down, it's going to cross the y-axis at 0.16 way past my graph. But I do know, once again, it comes through the x-axis right here. It would turn at some point and come right back up here, and it would end. Oh my goodness, look at this. It would end in a positive slope, just like it started. So I know it starts positive. It's so hard for me to draw lines on this tablet I use. It would go anyway. So I know that cubic functions always have that dip in them. And so I can't find exactly what it will be without using calculus, which we're not doing, but I can kind of estimate what it would look like. So I actually found a real picture of it graphed, and this is it. Now I realize my graph didn't have big enough numbers on it, but I started out in a positive manner. I crossed the x-axis at -4, I knew it had to turn at some point, and then it's going to cross the y-axis at, we knew it was 0.16. It went through the x-axis at 1,0, had to turn around and again cross the x-axis at 4,0, and then end in a positive slope as well. So it's hard to get it exact without using calculus, but we can kind of get it out. We know how it begins and how it ends, and we know where it's going to cross the x-axis, or the different place is going to cross the x-axis, and the place is going to cross the y-axis. All right, guys. So Friday's assignment is basically this sheet right here. So I want you to not only factor these by setting them all equal to 0, which is how they're written. I would like for you to add the the vertex. I want you to add the vertex of each point, so that if you graphed it, you would know either the minimum point or the maximum point. Okay, so for example, I want two numbers that multiply to give me 12 and add to give me 7, which is going to be +4 and +3. You're going to take both of those numbers, set them equal to 0. And then if you would subtract 4 and subtract 3, you would end up getting x is equal to -3 and -4. Okay, so that's the answer that you're looking for on the bottom of the page. We're not leaving it like this anymore, because now all of these are set equal to 0. So you're actually solving for x. So the x-intercepts would be -3, 0 and -4, 0. But you can keep your answers like this, okay? However, I am asking you guys to add that. Not only are you giving me the x and what the x values are, I want you to also tell me what the vertex of this line would be by using -b over 2a. -b over 2a. You're going to use that. You're going to find out the x value, and then you're going to plug in to get the y value. Okay, so let's do it on number 1. So a is 1 and b is 7. So the opposite of 7 is -7 over 2 times a, which is 1. So -7 over 2 is -3.5, or you can leave it as -7 over 2. That's the x value. So let me write that right here.
Melissa Madrigal, please come to the front office for checkout.
And then we're going to plug that in to the original equation. And you, of course, can use your calculators. but we're going to do negative 3.5 squared right here plus 7 times negative 3.5 plus 12. So I'm going to plug it in my calculator, parentheses, negative 3.5, parentheses, squared, plus 7 times negative 3.5 plus 12, and I would get negative 0.25 or negative 1/4. It doesn't matter. Either one of those works, okay? That's how you guys are going to do all of these. So you're going to give me your two values, the values of x. X is equal to these two numbers, and I want you to give me what the vertex is, okay? All right, you guys. Well, let me know if I know these were both very long videos and they're both for the same day, but that's what we're doing, okay? And we probably need to meet. Why don't we try to meet Friday also? And let me see if you have any questions. So maybe I will set our Zoom up for 11 o'clock on Friday, April 16th, Friday, April 16th. So y'all look for that in your Canvas page, all right? All right, you guys, I know it's a lot, but you can do it. Y'all are the cream of the crop, okay? Well, have a great day, and I will see you guys later.